Hi, so I'm here representing Giveth. My name is Griff Green, and I'm doing all the scaling research and starting really pushing the Scaling Now agenda. And I'm here with
Loredana. I'm from Brainbot. I've been working on µRaiden and Raiden Network.
Yeah, and obviously you're one of the big names in scaling. Raiden Network is the one that's really doing it and pushing forward the agenda and has been for a while. So I'm really excited to start the state channels discussion with you guys. You guys have, in general, let me just you guys have some big dreams with Raiden, and I know you've deployed it to Ropsten and it's ready for being tested. And I encourage all the dApps that want to go with Raiden's full implementation to start playing with it. But I really want to focus on µRaiden, which is deployed to mainnet and actually ready to be used today. So if we can stay mostly on that topic, that would be cool. And a little bit about our audience. We are in this discussion, if you want background information about how state channels work and all of that jazz, there's great information out there. That's not what this is. This is more a discussion focused on providing information for dApp developers that have a solution that they want to scale ASAP. And maybe, of course, they don't understand all the details about the solution, but they're not rookies and they can go look it up. So let's stay really technical and dive deep. So let's start with what dApps are likely candidates to use state channels in general, and what subsections of those dApps are actually good candidates for µRaiden.
Okay, just a disclaimer first. I'm new on Raiden Network, so my colleagues until now have done all the work. So just for people to know, I've been working mostly on µRaiden and some other projects. Okay, so state channels. With state channels, the idea is that you can have an unlimited number of off-chain transactions among a defined set of participants. So use cases would be, for example, any application where you know exactly how many participants and who they are, and you have some predefined set of rules. So for example, you can build a chess game because participants can agree upon the final state of the chess table and sign on that state after each off-chain transaction. Now, with payment channels, the state changes are actually digital currency balance changes for each participant. With µRaiden in particular, these payment channels are unidirectional. So you have defined and unchangeable roles for each channel participant. You have a sender and you have a receiver. The sender is the one that actually does the off-chain micropayments to the receiver, and the receiver is responsible for actually running the µRaiden proxy server. The sender only needs something like MetaMask to interact. Now,
nice.
The general use case is the need for free, fast, and frequent micropayments with a many-to-one setup, just because you have this unidirectional channel. So specifically, any application, not only decentralized applications, but also regular non-crypto applications that offer a service to users and want to accept payments in tokens, they can use µRaiden. And the users can be human or even other applications, but ideally there should be this need for them to make frequent payments. It's not efficient to use µRaiden for one-time payments, for example.
Okay, so you know, you go to the website and someone is constantly paying small transactions as it goes. That's like the perfect use case.
Yes, you can think about paywalled resources like news articles or research articles, or for machine-to-machine, where you want to query a payable API, like knowing the price per kilowatt for energy, for calculating the energy cost on the fly, or doing some prepaid payments for using a Wi-Fi bandwidth.
Yeah. Okay. Well, can you explain the basics of how a many-to-one µRaiden payment channel would work, especially with deposit requirements and the requirements of actually using RDN tokens? Do you call them RDN tokens? You know,
yes,
all that kind of stuff.
Yeah, that's correct. Okay, so the unidirectional payment channel that µRaiden uses is quite simple to understand. So you have a sender and a receiver. The sender is the one who opens the channel, who does the deposit of tokens, who can top up, and then can do the micropayment to the receiver. And we just keep track of the last balance proof from the sender, which contains the total amount of tokens that the sender owes the receiver. And we use that to close the channel, or the receiver can use that to actually withdraw tokens and leave the channel open for future use. Now, about the tokens, µRaiden can be currently used with any ERC20 or ERC223 token, in the sense that decentralized application developers will have to deploy their own µRaiden smart contract themselves with the token address that they want as a constructor argument. However, if they do not want to worry about contract deployment on the mainnet, or they want their users to feel secure that they are actually using the same contract that everyone else is using, and they know that that contract has been audited, then we provide this off-the-shelf solution that uses the Raiden Network token, or RDN.
Interesting.
Yeah.
So if someone doesn't want to deal with creating their own currency or anything, let's say it's some already established normal company, they can just use Raiden Network off the shelves as their payment solution, and people can even use PayPal or something to put money in, and they just handle that whole thing and buy RDN tokens for them off the market.
Yes, that's the idea. The idea is to actually provide something off the shelf and very easy to use, and then it can be actually very it is customizable and flexible if you want it to be.
Yeah, so if I have my own dApp and my own currency that I want people to use, I can actually just fork your code and change one argument basically, and boom, I have it µRaiden working with, I don't know, micro Swarm City tokens or something.
Yes, you can do that. You just have to take care of deployment and yeah.
That's very interesting. That's very useful. So do you offer pretty hands-on support for early adopters? How do you integrate with people that are starting to use this service?
Yes, so we are currently working on providing good documentation and tutorials, and developers can use our µRaiden Gitter chat to ask questions anytime. And we actually encourage developers that want to use µRaiden to get in contact with us, because we want to build a good framework alongside the community. So yes, we offer support.
Do you have many people that are starting to use it?
Yes, we know a couple of projects that have started to use µRaiden, and even some that have started to port it to Java, for example. And we are in contact with them and keep them updated.
Oh, that's very cool. Okay, good. And then I know that there's an active bug bounty going on. Can you talk about that a little bit?
Yes. Yeah. First, we would like to thank all the people that have reviewed the contracts during the bug bounty. The bug bounty has ended for now, and there were no serious bugs found. But however, it did trigger some code changes. And you can find more about that on our blog posts and GitHub issues, because we try to document everything. We are currently waiting for the sign type data EIP 712. It's a signature standard proposal, and we are waiting for it to be finalized, because it will require some minimal smart contract changes. So after that, we'll have another bug bounty period, and only after that we can make sure that we can have a stable production-ready release. And we want to make sure that what we're offering is secure, and we also want a good user experience for the senders, because this signature standard, you can see exactly what you are signing, and the risks of using a malicious, decentralized application are much lower.
That's really good. Are you guys pushing that standard, or is there another group that's really pushing that?
For now, there's another group that's pushing the standard, but we are watching it closely, and if we see anything that we would need and it's not there, or we can, we'll contribute.
So if someone starts using this and all of a sudden you guys find a decent bug in the system through this next bug bounty, what would happen? Like if you needed to upgrade to a new contract, how would a dApp deal with that? Can you ponder?
Yes, at this point, if we upgrade the contract, we don't actually migrate the channel data automatically. So the channel participants would have to close their channels on the old contract and open new ones on the new contract. In terms of gas cost, this is not actually that bad. It would be like 86,000 gas units per channel close. But we have thought about this, and we actually have the process documented in an issue. It usually boils down to, do you offer an immutable contract for people to use, or where they actually know what to expect in the future, or offer a contract that might change? So in the second option, you also have to start thinking about whether you force an upgrade for your users, allowing them to choose, or allowing them to choose and implement some kind of consent system. So these are the dilemmas. But for now, we've decided to stick with the simple and clearer path of having an immutable contract.
Good. Yeah, I mean, keeping it simple is always the way. So that sounds good.
But regular updates for the µRaiden proxy server package can be made without any issues.
Cool. Can you go into more of the details on what DApp would need to use for both scenarios? So it's kind of two questions. So like actually, if I'm Newsweek and I want people to pay in Raiden tokens to start viewing my website, then what would they actually need to do to implement this? Like step 1, step 2.
Yes. I'll actually show you some code examples to understand it better. But first, let me give you a bit of details about what components we actually have.
Okay.
So µRaiden has a Python proxy server, has the smart contract, and we also built 2 client libraries, one for JavaScript and one for Python. Now, the proxy server is the core that actually handles the off-chain payment logic. And the receiver needs to run this in order to be able to receive micropayments. We've made it in a form of a Python PyPy package, so it's very easy to install and use and run. And with just a couple of lines of code, you can already bridge your API that you have with µRaiden, so you can make it payable. The proxy also comes with some tools to help the receiver close all the channels in case it needs to, or to withdraw all the tokens that he has in the channels. Yeah, and then you have the smart contract, the one that stores the channel information on chain. And you have an interface for opening, topping up, closing the channels, withdrawing tokens. What's nice about the smart contract is that you can use a delegate for doing these things, for opening, topping up, and for the cooperative close. So this kind of opens up more features that can be built on top of µRaiden.
That's cool. Can you talk about the cooperative close? That's interesting.
Yes, but can I finish with the components first?
Absolutely.
So then you have the 2 client libraries, and these are to provide a good interface for the sender to use the system. The JavaScript client library, we have this as an npm package, so it's also very easy to install and use. So it contains all the µRaiden related logic. So if you want to actually customize the UI, you can do that. You can have everything that you need in this library. And then you have the Python client. This can be used for machine-to-machine scenarios. Because the other one, the JavaScript one, is like a paywall. You manually open and top up channels. You can see that in our demo videos. But the Python client can be used for machine-to-machine. So you just give it some configurations, some limits to the tokens. It opens, it tops up channels automatically for you. And but it needs to be run on a sender's machine and needs at least an Ethereum Lite client.
Oh, okay.
We have used this for a demo with a querying Ether price in US dollars, and I've also used it for a drone demo that I made recently at a Berlin Ethereum meetup. So now either the cooperative close or the code examples to run through what do you want to?
Okay, well, cooperative close, and then also I'm curious about. I think it piggybacks well off of. Maybe we'll start with this before we do cooperative close. What would someone need to do to fork µRaiden if they want to use their own currency? Because they have to do all those services still that you just explained for someone who's using µRaiden. What extra piece do they need to do if they want to fork it?
Okay, I can answer to this question right now. Aside from handling the token code or what, and deploying the µRaiden smart contract with the token address, they wouldn't need to do anything else.
Wow. Okay.
So well, if it's the same interface as we use now, if it's another interface for transferring the tokens, they need to change. They need to change a little bit of code, mainly the smart contract. So if, for example, because we used ERC20, ERC223, if the interface of the token is different than this, you need to modify a bit from the smart contracts where exactly where you do the token transfers. And then probably the client code that also handles this. But the proxy server remains totally unchanged.
Nice. Well, that's really cool. You guys have made a very modular system. Okay, so cooperative close.
Cooperative close. And can you see my screen? I think so.
Yeah.
Okay. We have, so this is part of our current documentation, and you can see a bit of, this is the smart contract part. And you can see how you can open a channel, top up. I'm not going to show you this now because anyone can look at it. But here we have a nice diagram to kind of show what happens. So for example, you open a channel is created, you have some off-chain transfers. And then what happens when you need to close the channel? So we have two. We have the cooperative close and uncooperative close. What does cooperative close mean? It means that aside from the balance proof, which is signed by the sender already with the last balance, you also need the receiver's closing signature on the same data. Mm-hmm. So if you have this, you can close the channel immediately and you don't go through a challenge period. So this can be called by the sender directly, by the receiver, and by any delegate that you want.
Oh, okay.
If you want a bit of details about the uncooperative close, in very short words, the sender can call close. Let's say that the receiver is not online, so he can just call close with his balance proof. And then you just have a period where the receiver, in case the sender didn't send the correct balance proof, the receiver can come in and say, okay, this is the last balance proof that I received, and then the channel is automatically closed. Or if the receiver is still offline after the challenge period has ended, then also the sender can call settle channel. So it's, yeah.
In application, though, the receiver is going to be some large company that can probably maintain a node's uptime, right? Is that kind of the assumed?
Yes, that's the assumed idea.
Okay. So this is really just if they decide to close their business and run away, then
there's no problem. Nobody loses his tokens.
Yeah. Okay, that's pretty cool. So on the UI side, what about the wallet for managing off-chain balances within the channel? I assume that's also pretty easy to fork and customize.
Yes, we provide that JavaScript npm package with all the logic. You just need to customize the UI a little bit.
Is there anything that people should be careful about? Any potential, common failure mechanisms that you might see?
Not µRaiden specific. They should take care of things like decimals, for example, but these are the usual decentralized application issues that you can have.
Yeah. Okay.
The token decimals, to not, Yeah.
Of course. Yeah. Okay. And how much gas does it cost to open and close the channel? Depositing is just transfer an event, but then withdrawing.
Okay, so for opening a channel, you have about 90,000 gas costs. If you use the ERC223 interface, you open the channel and transfer the tokens in the same transaction. If you use the ERC20, it costs a little bit more, like 120,000. Topping up is around 60,000 gas cost.
And that's just because that's how much it costs to transfer a Raiden token, pretty much?
Yes, and you also need to modify the deposit variable, because so the actual channel data that we store is how many tokens you have as a deposit, and then the block number at which the channel was opened, because this is part of the channel ID.
Okay. Yeah.
Then you have the cooperative close, which is the best case scenario, because you have only one transaction. It's 86,000, and the withdrawal, the first withdrawal is a little bit higher, around 70,000, because you also need to store on chain how many tokens you have already withdrawn. But then the subsequent ones are like 50,000 gas.
These are all very reasonable gas prices, so that's pretty efficient. And well, actually, my next question was about the dispute resolution process, but you kind of already explained that. Is there any other details on that you think are relevant to people?
No, not really.
Okay. And then when Raiden is implemented, dApp tokens will be able to be used directly in state channels through Raiden. Is that correct?
Yes.
So if a dApp starts using µRaiden right now, but then later wants to transition to a native token using Raiden, how would that transition end up?
Currently, there's no way to migrate users from µRaiden to Raiden Network, other than just closing the channels on µRaiden and opening, if necessary, new ones on the Raiden Network. They're just different systems, but I think that µRaiden channels are efficient enough for this to actually not matter in terms of cost.
Okay, yeah. And so when Raiden is developed, do you imagine people still using µRaiden, and then Raiden just being like basically these are two separate projects?
Yes, if the use case remains the same, frequent payments, they might actually continue using µRaiden, if at least at first.
Can you just dive in very briefly, and then we'll end the call, but very briefly into the Raiden solution and how it differs from µRaiden?
Okay, so µRaiden has unidirectional channels, like I said. Raiden network channels are bidirectional. But what's actually nice about µRaiden is that you can use the whole network of channels. So you don't necessarily need to have an open channel with the person that you want to send tokens to, the person or company or service or whatever you want. It can route the payments through the network. So because I said with µRaiden, one-time payments are not very efficient. You have to do frequent ones. With Raiden Network, this doesn't even matter. Another difference would be that for µRaiden, these off-chain payments are free, just because you don't need intermediaries. With Raiden Network, it would also depend on some fees to actually use other people's channels. It's these are some of the differences between the systems.
Very cool. Well, thank you so much. I mean, it sounds like it's ready to use now, which is really exciting for people who are looking to scale their dApp. The ecosystem has grown to the point where there are real dApps that need to get going. So thank you guys so much for your work. Will you be coming to Barcelona on March 6th?
I am not sure. We are as a company. I'm not sure if I'm personally coming.
Come on.
But yeah, what I wanted to say is that the complete class of micropayments for APIs can be built on Ethereum-based micropayments now. So check out the project, give us feedback, and you don't have to look any further than µRaiden for fast, free, and frequent payments.
Oh,
we're here.
What a tagline! That's good.
Yeah.
I like that. Well, and whether you come or not, you're just going to miss out on the party if you don't show up. But there's a big event on March 6th that if you guys are interested in learning more about Raiden or counterfactual or also all the bridge chain solutions, there's going to be a great small little gathering that's specifically for dApps that have something to scale right now. So if you are able to come to Barcelona on March 6th, there's going to be some links down below so that you can get that information for the application to come. And hopefully Loredana will bless us with her presence. Either way, Raiden will have a lot to say. So if you want to implement Raiden's solution, come to Barcelona. And thank you so much. And I will talk to you soon.
Yes, thank you very much.
Thank you, guys. Bye.